Okay, let's go through this. So when I see problem 1, what I like to do is I just start numbering the carbons, 1, 2, 3. And once I get to a parentheses, that's kind of where I stop. And so I'll just draw those 3 carbons. Okay, there's the zigzag right there. Those are the first 3 carbons. And then I pay attention. I see that this is carbon 1, carbon 2, carbon 3. Carbon 1 as drawn in the skeletal structure, does it have the 3 hydrogens? Yes, it does. Does carbon 2 have 2 hydrogens on it? Yes. Now, does carbon 3 have only 1 hydrogen? No, it has 3 hydrogens as drawn. But we see that there's only 1. But what is directly attached to carbon 3? A methyl and another methyl. So there's 2 methyls right there, which are attached to carbon 3. Okay, and so I'm not going to number those methyl groups, but now you can double check and triple check yourself. How many carbons are in this molecule? 1, 2, 3, 4, 5. Is that how many's in the condensed formula? Is the hydrogen count the same? If that is, then you're on a good, you're like 99% or 90% there. Now you just need to make sure the connectivity of all the bonds are correct. And so that would be the answer there for question 1. Now many students freak out. Like, well, what if I drew it like this? Do you see what I did there? That's carbon 1, carbon 2, carbon 3. It's the same molecule. It's just I started my zigzag up on this one. And over here, I just started it pointing down. If I took this molecule and just flipped it 180 degrees on the vertical axis or the horizontal axis, I would get this. It's the same thing. Now, what if we start with molecule 2 there? I see that there's 1, 2, 3, 4 carbons. There's my 4 carbons. 1, 2, 3, 4. I see attached to carbon 4, I have 2 methyls again. So I'll go down and then up like that. Now, I have the carbon count correct, but this carbon 2 only has 1 hydrogen. The way I've drawn it, I have 2 of them on that carbon. Do I not? And then carbon 3, I have 2 hydrogens when it should only have 1. Carbon 4 says I only have 1 hydrogen, which I do. That matches perfectly for carbon 4. So how do I get this to match my skeletal structure? Just put a double bond. Question up top? Does that make sense? Now look at that skeletal structure. Does that carbon 2 only have 1 hydrogen? Yeah. We don't need to draw it, but there it is. So on the exam, draw it like this. Draw in all your hydrogens that you want to make sure it's correct. But then you need to clean it up. Draw the molecule again because I asked for a zigzag structure. And zigzag structures don't want hydrogens. So just redraw it. Like this. And so that would be your correct answer and your final answer. So you have to be very, very careful, class, to follow instructions. Because if I say, take this molecule right here and draw the zigzags or the line structures, you know how many people are going to draw the answer look like this? CH2 and so forth, and draw it out like that. That's not a zigzag structure. It has to be the lines. So be very, very cautious. Okay? Doing it the way that I need it drawn. Yeah, question?
Will we get pointed for see how on the first one you put 1, 2, 3 to number your carbons? Will we get pointed if we just leave those 1, 2, 3 there?
No. But I would just, no. If you put the numbers there to help keep track of things, that's fine. But the moment you start drawing in hydrogens and it just gets messy, that's not a skeletal structure. Any other questions about this particular example? Yeah.
When we're drawing the skeletal structures, do you want us to draw in like the wedges and the dashes or no?
Well, in this particular example here, what would be the wedges and the dashes in this problem right here? In that problem right there, the only thing that's wedges and dashes would be the hydrogens. And so I don't want those like that. Okay. Now, on this one right here, this is where people get a little confused about that, is because that carbon right there, do you see how there's 3 bonds in the same plane? But what is the hybridization state actually? Or what is the hybridization state? It's sp3 hybridized, that carbon, so it should be tetrahedral. Right? And in this particular example here, it would be a whole lot more accurate if you drew it like this. Okay, we would have our wedge there. But something that you'll learn a little later on, because this is not a stereocenter, we can just draw it like this, which is a little inaccurate because there's going to be free bond rotation around here. Okay. So we will talk more about what a stereocenter is, and that's when we will really delve deep into drawing the wedges and the dashes. So for right now, if I say draw skeletal structure, this is what I'm looking for right here. Okay, that type of thing. Good questions. Any other questions? Yeah.
For that second one, let's say the CH3 that has the parentheses and the 2 from it. If it's instead written as CH3, does that mean that it's going to come off as like that 4th carbon is going to come off CH3 and the CH3 and help with that metal?
So are you saying to get rid of the parentheses?
Like if in the parentheses it's just CH3 and then CH3 written at the end instead of CH3 with the parentheses too.
So you're saying like this?
Yeah.
You will never see it like that. Because if you write it like that, that is implying that this carbon right here is going to be bonded to that carbon.
Yeah, that's basically what I was asking.
And so that you're violating the octet rule if you draw it like that. Okay? Because this carbon right here, the way you've drawn it, says it's bonded to this carbon. But no, it's actually bonded to that carbon. Yeah. So we don't do that. Okay, so for question 3 there, I like to number things. 1, 2, 3, 4. We could even go 5. Now the numbering scheme is just, well, scratch that. So what I want to do is when I number it, I typically number it with the longest carbon chain. And then we have a methyl group right here, our CH3. That's a branch point. So with respect to that long carbon chain, we have a methyl group branching off of it. So I'm going to draw carbons 1, 2, and 3 first. Wait, never mind. We want to draw it out. So we would go CH3, that's carbon 1. Then CH2, that's carbon 2. How many hydrogens are on carbon 3? Only 1. So CH. Now, that is carbon 3, and we know it's bonded to carbon 4 right here. Okay? But we also know carbon 3 is also bonded to this methyl. So we have to do the branch point first. And so that branch point right there, that methyl, we're going to put it into parentheses. So we have 1 methyl branching off of carbon 3. That's what that's saying. And then you proceed to go CH2, that's carbon 4. And then you get to 5, which I'll show you in a second. But we have a question here.
On the carbon number 3, how do we know that's a methyl and not an ethyl?
How do we know carbon 3 is a...
Like the line that's going down carbon number 3. How do we know it's a methyl and not a methyl?
Because you'll learn that a methyl means one carbon. Ethyl means 2 carbons.
So how do we know there's 2 carbons there?
There's no 2 carbons, there's only 1. So this carbon right here, that's just 1 carbon coming off of the branch. So that's a methyl group. And so we have one of the methyls. That methyl in parentheses is this guy right there, which is attached to carbon 3. Now, this is very, very important. What type of functional group do we have here on carbon 5? What's the functional group?
Aldehyde.
It's an aldehyde. Aldehydes, you write CHO. That is an aldehyde. If you wrote it like this, COH, that's 100% wrong because that is an alcohol. So the order in which you write these means different functional groups. So we said aldehyde, so it has to be written that way. Now I know I'm out of time here, but I want to take 30 seconds here. This carbon right here has a formal charge of +1. So you got to relearn and review formal charges. So because that's a +1 charge, how many hydrogens are at that carbon there? There's 0 hydrogens. So how many groups are around that carbon? Electronic groups. 1, 2, 3. So what is its hybridization state? sp2. Okay? Okay, see you guys on Thursday.